Okay, it's that time, so let's do this. Where do I want to be? I want slides. Give me some slides. All right, some more unit testing. We talked about this a bit on Monday, and we have one lecture question, so you got a little bit of hands-on practice. Those of you who did it. Those of you who did not do the lecture question yet, by the way, those of you who are relying on the later deadlines, just know that if you haven't completed Monday's lecture question by now, you are behind in the course. You are falling behind already, and it's going to be very difficult to catch up in a course like this. Every lecture is introducing more concepts, with very few exceptions. I mean, today, technically, it's not a brand new concept, but we're showing more complex ways to use and apply unit testing. The content will come very fast. If you are saying, well, the due date's not till way later, I'm not going to worry about this lecture question yet. Just know that you're going to fall far behind. When I have students at about the midpoint of the semester, the students who are relying on the extended deadlines, they'll come to me. You'll end up coming to me. Of course, those people probably aren't even listening to me right now. But if you're watching this on YouTube, you know you're already behind. They come to me mid-semester or even later. The later ones are just completely screwed. And say, I'm far behind in this course. I need to catch up. What do I need to do? And unfortunately, there's just not much that you can do at that point. If you're trying to cram this very difficult 14-week course, excluding fall recess and finals week, this 14-week course into 7 weeks, good luck. I mean, you have to double that 12 hours a week. If you're putting in 24 hours a week, sure, maybe. But get on that. If you haven't done Monday's lecture question yet, you are falling behind. Get it together. Start working hard. Or you're looking at either an R or an F on your transcript, which nobody wants, including me. I want to see you all succeed. So, get on that. Yeah, 200 plus to 130. The attendance does, as you know, just being in college, any course that doesn't require attendance does drop off fast. I have been considering, I might even go back to required attendance, because it's just ridiculous how irresponsible some students can be. And I don't even know how much I can blame them. It's kind of human nature. But anyway, enough of that rant. Let's get into unit testing. And the reason I do that rant today is because today's lecture question is a very healthy increase in difficulty. In my opinion, in my mind, this is where the course really starts. No coincidence that it's the first lecture after ad drop, so I know the course list is finalized. We have everybody who's going to be here is here, and everybody who's not isn't here. The ones who actually literally dropped the class, I mean, who aren't registered anymore. So this is the first real more challenging lecture question. Those of you who skated through the first 3 lecture questions, this one you might have to think about a little bit. So what are we doing here? We want to come up with the prime factorization of any integer. So in a package named lecture, kind of same ordeal here. Package named lecture, create an object named algebra with a method named factor that's going to take any int and return its prime factorization as a list of ints. If the input is either negative, 0, or 1, return an empty list. There's no prime factorization to those values that is really meaningful. Don't include 1 on, this should say any inputs. Don't include the value 1. I thought I updated these slides. You know what I didn't push? I'm not going to bother with that right now. I updated these slides, but I didn't push. That's the only thing I did was delete the word other. Don't include 1 in any of the outputs. So if the input is 2, just return 2. That's its prime factorization. Don't include 1 or the number itself, like 10. 10 and 1 wouldn't be in that list. You would just return 5 and 2. So, and any other ones, the order of the list of factors does not matter. So if we factor the value 12, all 3 of these outputs are valid. 2, 2, 3, 2, 3, 2, or 3, 2, 2. So in your testing, you have to take care of this. You have to address this this concern that any one of these 3 lists are valid. So any permutation of the prime factors, any ordering from the list, has to be accepted as an answer. So yeah, for the example in chat, it could either be 2, 5 or 5, 2. Both are valid answers. And we'll talk about how to address that. in today's example. Today's lecture is going to be a lot of IntelliJ, a lot of live coding and examples and walkthroughs, and I'll try to interact a little. It's a little bit packed of a lecture, but I'll try to interact with Chad a bit. I'd rather do that than just go through my script. And finally, writing the test. How do we test this thing? Write a test for test factoring, which will thoroughly test the factor method. And it's going to follow the same idea that we did for the last lecture question, as where I'll have correct and incorrect solutions in AutoLab. And we'll talk about what that really means in more depth today. Yes, there's a dot sort method, Dennis Grace, and that's part of what we'll talk about. So if you don't want to be left in suspense, we're going to sort the output list, and then the test list will have already sorted in increasing order, or non-decreasing order, and then use equal equal. You can use equal equal. You're stealing my thunder here. Yeah, use sort and use equal equal is the quick answer. So let's do a quick walkthrough of Monday's lecture question. This question is a very simple question, but you're learning a new thing, this unit testing and just the structure that's set up. In some of the incorrect solutions on AutoLab, I noticed that there's a bit of just confusion about what's being asked. So for this first unit testing lecture question, I want to walk through the solution. I'll code up my solution and show you exactly what to do on this one and what the solution looks like. So, of course, nobody should not have credit for last Wednesday's lecture question and this Monday's lecture question, because I'm giving you the damn answer in lecture. So there's no excuse at all to not have those ones done. If anybody doesn't have those after, like 24 hours from now, I'll know that you're just not even trying. That 24 hours would compensate for like time zone differences and everything. You're just not watching the lectures on time at that point. Anyway, so I showed you these 5 incorrect solutions. What we need are unit tests that will, if the input is 11, you should return a list containing 11. If it's any prime, the prime is its own prime factorization. So I gave these 5 incorrect solutions on the server, and that caused a little confusion in some of the submissions I saw, so I want to clear up what that is. When you submit your tests, in your code that you submit, you don't care what these are at all, but your test should be thorough enough that it will reject all 5 of these incorrect solutions on the server. Can you give more examples? This lecture is all about examples. So let's go right to IntelliJ. I understand the need for examples, and I try to get examples in lectures whenever I can. Today is one such lecture. We're going to see some examples. So let's walk through this lecture question, and I want to back up one on my slide. Back up to here, just so I can refer to the lecture question. So if you see me looking over here, I'm looking at the lecture question. I know you can't see it on your screen. And I did resize IntelliJ as well. Let me know if the size is fine. I believe the Moisby, I can't exactly slow down. There is a lot of content in this course. I can't. I saw you asking before. I see you asking now. I think that was you asking before. Yeah, more slowly. I can't just slow down the entire course. But so I realized IntelliJ was smaller earlier. I was just showing quick examples. Since today, like the whole lecture is in IntelliJ, I had to resize it. So let's get started. So in a package named lecture, create an object named first object. So I created a new project. The only thing I did here was create a brand new project. It's actually the one I created last time. I deleted all the stuff in it though. So I'm going to create a new package where my code is going to be contained. Lecture, lowercase l, and enter. Now I have a new package which is going to store my code, and this is a way that we can organize our code a bit better instead of just throwing everything in the src directory. I'm going to create a new Scala class. I actually don't have Scala as an option right now because I don't have my SDK set up. If you do run into this, we'll see how to fix it completely. For now, I'm just going to create a new file. Do I want to do it? I don't want to do it that way. I'm going to go to project structure. I'll show the fix first, because then I don't have to worry about some other things. And find my Scala SDK, which actually looks like it's set up fine. Oh no. I think I unlinked it because I intentionally broke it last time. Oh my goodness. So I'm going to go back to the plan A. I'm going to create my object and I'm going to put the .scala extension on it. I can't hear you ever, but I can read your chat. First object.scala, and now I get my message here. Scala SDK not set up, which was strange because it was set up. I'm going to choose my SDK, my 2.12.12. I'm going to make sure it's a version 2.12, and then the last one, just take the highest version, which is currently 12. Oh, yeah, you can't see the submenus. Sorry about that. When I clicked that, I didn't choose any options. It just popped up with choose your Scala version, and then I clicked OK. I forgot that you can't see the pop-up menus. Then read our chat, Hartloff. I'm trying to just pick up when I can with chat. The chat's... I just missed that one part. But yeah, you can't see the pop-up menus. I was aware of that from last semester, but I definitely forgot. So I do have to build this object from scratch since but you didn't miss much on that pop-up menu. I'm only capturing the window, not the desktop. Right, that's how I zoomed in. That's how I scaled the size. IntelliJ doesn't really have a good way to zoom in or increase the font size without breaking a lot of things. So yeah, I'll just remember that you can't see the menus that pop up. But what I did to create you can't see those. So I right-clicked SRC and went to New Package. I right-clicked Lecture and went to New File to create this. And then I typed in firstobject.scala as the file name. This isn't really what you should do, but if your SDK is broken, this is what you can do to fix it to be able to get through that. And then the notification that popped up on top that said your SDK isn't set up, I clicked on set it up for me. I already had 2.12.12 installed and downloaded, so I just clicked that. If you don't, there's a download button on that where you can download the appropriate version of Scala. So since I have to build this from scratch, I'm going to give the package declaration, which matches the directory, the package that I created. So package lecture, and then create my object, which is first object. And everything fixes. You see the symbol changed here to an object, aside from a Scala script file, and everything's looking good. Do I need to create my new project for every lecture question? It's fine to reuse the same one every single time. That, for what it's worth, I use one project for every lecture question for my testing. So I submit, even for the first lecture question, I just submit every single lecture question from last semester. And then as I create more, I just keep filling up the same project. So I had this first object. I need to create a method named compute shipping cost. This is normally where I'll be a little dangerous here, but this is where I recommend cut and pasting that from the lecture slides, just to make sure I don't have like 1p here instead of 2. And I probably have a typo because I'm prone to typos here. But compute shipping cost, exactly, no capital C. A capital C is going to give you a 0 on the assignment, etc. You should be familiar with all that kind of stuff, parts of programming from 115. That takes a double, representing the weight of the package. So this is going to be the input, the parameter list inside these parentheses. We have to specify the name of each parameter, then a colon, and then the type. And if we had multiple parameters, oh man, I accidentally hit a button there. Like if I had another parameter, and maybe it's an int, we comma separate that list. So that's how we would define multiple parameters. I only have one parameter, but I do have to specify a return type after the parameter list. The return type here is also a double, an equal sign, and then the body of this method. And right away I'm going to get this error, and I see this a lot on Piazza. The TAs have been great about answering this question a lot, but this unit with a error here, what this is saying is that and we can read the the error message. Hey, that one actually shows up on OBS. Type mismatch required double found unit. So when I say this method returns a double, this method has to return a double. Scala will enforce this. The compiler will enforce this. IntelliJ will enforce this. This method has to return a double. But I didn't return anything. And when you don't return anything, that we call that unit. And it's saying, you told me you were going to return a double. What the hell, man? You didn't even return anything. So once I return a double here, that error goes away. One of the big mistakes that we see... Oh, I'm thinking Python. One of the big mistakes that we see is if I have a conditional, I return a double, else if, and then I return a double. Now, no matter what, this is going to return 0.0 unless I have something really strange going on. But I'm still getting an error here. That's because I don't guarantee that I'm always returning a double because I don't have any else. Scala isn't going to look at these conditionals and check if they're always going to be true, if these options are mutually exclusive or whatever. It's not going to do that. It's just going to say, if this is false and this is false, you're not returning anything, and you told me you were going to return a double. We can get around this by making sure we always have an else. The else is the catch-all. Now, one of these three will always execute no matter what, and we're going to get our proper return value. There's a little side note, but that's was like half of the questions on Piazza were related to that, so I wanted to mention it. All right, so now shipping cost is £5 if, and this is one of the problems, I should have just done that example with this lecture question. If weight less than 30.0, return 5.0, else 5.0 plus 0.25 times weight minus 30. So there's the answer to last Wednesday's lecture question. That's how I would code it up. Notice I have an else here. If this is an if, else, weight greater than equal to 30. This is, again, is an error. Wow. I'll get there. Else if. This also gives us that error before, and this is something we see a lot for this lecture question. I have, if both of these conditionals are false, and our logic tells us that they can't both be false, but if they're both false, there's no guarantee that this method returns a double, because either this is true and we're returning this, or this is false and this is true and we're returning this. If both are false, there's no else to catch us. So a good way to get rid of that is to make this an else. If you expect your options to be mutually exclusive, why not have it as an else? It doesn't have to be less than or equal, because if it's equal to 30, this is going to be 0, which means this will be 0, and I still have just 5.0 right here. So I get the same answer no matter what. Just because this will 0 out, I'll have the same thing. This code is functionally identical, whether I have the equal there or not. So we have our code complete for that. We have our piecewise function that's either going to return 5 less than 30 or this function greater than 30 with arbitrary decisions at 30. But now we have to do the testing, which is the good part that we want to talk about today. So in a package named tests, create a Scala object, a Scala class. Create a test suite named unit testing, which is going to be a unit test suite. I don't have my pom.xml, so I'm going to go to new file. I know you can't see that part, so let me explain it. I'm going to go to new file when I right click on the project root itself, and it's going to ask me to name my file. I'm going to name it pom.xml. I'm going to cheat a little bit here. I'm going to go to my examples repo. I'm going to find that pom, and I'm going to cut its contents and Control V, paste its contents right here. Bam. I got my everything I need here, including the only one we're using today, Scala test, to be able to say that to download this dependency. I don't have Maven on my sidebar, so I'm going to search for it. Add as Maven project. And at this point, I should be able to... I don't know the shortcut on Windows. Alt-Enter. I thought I did that. No. Man, it's 2020. I shouldn't have to type this manually. And import my Scala test functionality so I can get that fun suite. Create a test. I'm going to name my test something meaningful. Check shipping costs. I guess not super meaningful. And then I'm going to finally write my tests at this point. So now we get to the good stuff. We need to test this functionality of compute ship cost. Is it compute ship or compute shipping? So we're going to import. Since we're in a different package and we want to use code from oh, mod, you didn't have to delete that one. Unless there's, I might have missed something though. I'm going to import from that package, from lecture. I'm going to import first object so I can start testing. Assert first object dot compute ship cost of like 2.0 equals 5.0. And for those of you really watching, really paying attention, I am going to do something bad. Don't worry, I'm doing that intentionally, and I will fix it later, but I want to make a good point here. So we can start adding some assert methods here. 30 should equal 5. 31 should equal 5 1/4, etc. So we're going to have a bunch of unit tests here. But I want to show a better way to organize your unit tests. I did this a bit last time. You already lost me. I haven't even covered any. I mean, I don't want to be rude here. I'm not saying this to be rude, but I haven't covered any new material yet. This is all from Monday and before. So I'm going a bit faster now than I normally would, or the same speed you've seen all semester, rather, because there's nothing new here. So if you lost already, that probably means you're one of the people I was talking about earlier who skipped Monday's lecture question. You really need to complete each lecture question before the next lecture, or you're not going to understand the next lecture. I am serious about that. If you haven't followed this up to now, I know I can pretty much guarantee you haven't done. Actually, yeah, I can guarantee you haven't done the lecture question for Monday, because that's literally what I'm doing right now. Everyone should have already done this. So there's no reason for that. The only reason to go over this is if you legitimately couldn't understand that one, I want to help you out there. That's why I'm spending this time in lecture. And to show you some extra tips like what I'm about to show you. So we can organize these test cases in a bit better way. Yeah, this course is fast is like accurate. I've been warning you since last Monday. This is not a joke. This course goes fast. And it's not even fast by my choice. There's just a lot of stuff that has to be covered. I have to get you from the end of 115 to the beginning of 220-250 in one semester. It's a big task. There's a lot that you need to know. You cannot drag your feet because I can't slow down. I don't do that to be mean. I wish we could slow down on some of these things. We just cannot. So I'm going to create a data structure with my test cases, and I'm going to create a map that's going to map inputs to outputs. I have doubles as inputs and doubles as outputs. So I'm going to create a map from double to double. Remember, in Scala, we always have to specify the types of everything. If I have a data structure, I can't just have a map and mix types like we could in Python and JavaScript. I have to have a map that maps one type to another type, in this case, doubles to doubles. All the keys have to be doubles. All the values have to be doubles in this case. I'm going to create a new map and put my test cases in here. If I have 2.0, I'm going to use the syntax for map that we saw last week. 2.0, if that's the input, we should output 5.0. And right here, actually, let me get these three in there. 30 should return 5.0. 31.0 should return. Somebody asked this. Oh, bad time to say that. Somebody asked this before. If I put 31 here, Scala will be smart enough to convert that into a double for me, even though I provided it as an int. And once I have this map set up, I can iterate over those values using the syntax we saw for a map. I'm going to name the keys and values of my map, input and output, since they're test cases for this, and give the map that I'm iterating over test cases. And then put the assert right like this. Input, output, and I'm going to give myself a little bit of hint text. I'm just going to put the input. I'll keep it simple, which is, again, automatically, it's a double, but it's automatically converted to a string here. Scala does help us out when it can. And now, let's get rid of Maven here. And now, this code is going to iterate over my test cases and assert that each one has the proper input and output behavior. So now I can clean up my code a little. If I want to add a test case here, and I like organizing my, oh crap, Windows. What's the shortcut? I'll do it manually again. And if I want to organize my test cases, which I usually do, I think it's a little bit easier to read like this. So now we need a few more test cases here. I want to test some more boundary conditions. So like 29.9 should still be 5.0. This is where we get to the question of how much testing is enough testing. And I definitely want more testing than this. 100, I have to pull up my calculator here just to make sure I have non-broken test cases. 70 times 25, 17.5, 45.7, or 47.5. Let me do 33.2, which is 5.8 because I pre-computed that one for reasons. 33.2, and we had one more in the handout itself. 0.4 is 510. All right, so we got some test cases. For now, I'm actually going to comment these two out and run our test cases. So I think this is decently thorough. For more, we could add. No, don't do this to me. Okay. So we could add more test cases than this, but this will be thorough enough for this lecture question. We really just have one boundary to test. Then we want to test some extremes. One thing I did see, if you're still struggling to get credit for this lecture question, there's nothing in the lecture question that specifies what 0 and negative input should be. For the purposes of this, just this first unit testing question, you can just not test those inputs. But technically, according to the wording, it should return 5.0. Even if this is like negative 1,000, it technically should still return 5.0 because anything less than 30 pounds is just a waste of money. Or anything 0 or less is just you're wasting money to not send a package. I don't even know what that means. You're sending some helium balloons maybe. I don't know what's going on, but you're getting charged $5. So let's run these tests. I'm going to right-click unit testing. I know you can't see it, but I'm just going to go to run unit tests, and we'll see if this passes or fails. I didn't put 47.5 on there. And I got type mismatch. Oh, this might be a good one. It's behind my head here. But it is actually saying that it couldn't convert. So sometimes Scala tries its best but just can't figure it out. It is saying that 31 has to be a double. I wanted a double. You gave me an int. No, not going to happen. I really thought Scala handled that situation. But let's put our 0.0 in there. So I actually do have an error. That's what you're all talking about in chat. 22.5. Which I did return. I just apparently suck at math. This is why we use computers. I added 30 to the final cost instead of, working with the weight. For some reason, I added that 30 back in that I minused for the thing. Anyway, okay, we got the right code. We got some good testing here. But now what happens when we add in these two tests? What do y'all expect to happen? We'll see who's really paying attention here. And hopefully my math just isn't wrong. It should legit fail. So my math is right here. I expect 5.575 from this input. You can verify. You can check on your calculator. That is the exact output that I expect. The test fails because my method is returning this value, which is extremely close to 5.575, but it's not exact. They are not equal. This is something we have to address. We talked about it last Friday. This is the first time where it really comes up. If you only tested with whole numbers, you kind of got around this. But on certain inputs, you're going to have this double truncation error. You're not going to have exact values. Both of these inputs will have rounding. Actually, it did hit the second. Oh, because it's a math. So if I comment this one out, the other one's going to pop up and give me the same error, similar error. So if I check my output, 5.8 expected, but you actually gave me 5.8 and some very small value added to it. This is where we need to do math.abs. We've seen this on Friday. Minus less than epsilon. Typically when we have constants, we'll put them in all caps. I'm even going to put it out here. Don't worry if you... we'll talk about all that kind of stuff throughout the semester. I could easily put this right here inside the test, but I could use it across multiple tests, so I'll put it out here. So now I'm going to check if the difference between these two values is less than epsilon, call it good. Now I can bring in my test case. I can run it. Whenever you're comparing doubles, you have to make sure that you give it some wiggle room. Give it some tolerance so that you don't run into this double truncation error. Yeah, exactly. That's why I spent time on this on Friday, because it's a part of programming. This is something that, beyond 116, this is just something you need to know. The actual value of epsilon is kind of arbitrary. You can choose whatever you're comfortable with, but it should be, if it's too small, it needs to be large enough to handle these truncation errors. Oh, well, I kind of lose my error message there. But you saw how small the values were that the truncation errors create. It has to be large enough to allow for those truncation errors, but it shouldn't be so large that it actually interferes with your computation. So it's a little bit arbitrary as to exactly what you set epsilon to be, but it needs to be in between those two values. Large enough to take care of double truncation errors, but not so large that it messes with your whatever you're computing at the time. So for example, if you're doing computations where you expect the values to be extremely small, you really don't want too large of an epsilon. And that's this lecture question in a short amount of time, longer than I wanted to spend though. So let's digest that a little bit. I'll look at chat for a second. Yeah, all the irrelevant chat. Y'all got a lot of irrelevant chat going on. Why does epsilon not have a type? Because it just slipped my memory. So when you don't have a type, since this has a trailing decimal, this has a decimal portion, Scala inferred that it was a double that I wanted and chose that to be a double. But I should be explicit in my typing. Okay. I only got 2 examples today, but I still have to rip through these so fast. I know it's kind of dizzying. So these 5 methods, these 5 implementations of compute shipping costs exist only on the grader. So when you submit to Autolab, this test, what I do is take your test, whatever your test suite tests, run it against my solution. I run it against your code that you submitted with it, and then I run it against these 5, for this specific question, I ran it against these 5 incorrect solutions. And your testing has to be thorough enough to distinguish between the correct and incorrect solutions. So these, you don't need to do anything with these in your code. I did see that a few times where you were putting these in your code and in your tests. You don't need to do anything with these. I'm just letting you know what the incorrect solutions are that exist on the server that I'm running your test cases against. So I'm going to effectively swap out your solution with one of these and run your tests. Then I'm going to swap it out with another one of these, run your tests. Swap your solution out with another one of these, run your tests, etc. And then report what your test case did on each of these, and it should fail all of these. You should get red marks on this code if you put it in IntelliJ. So for example, if I cut and paste this code into my IntelliJ as this compute shipping cost method and run my unit tests, that unit test needs to fail. That's how I'm grading your tests during submission, when you submit to Autolab. So if there are more questions on that, I'll hang out the 20 minutes after this before 4:42. But let's move on to this next one. I at least want to get through the testing of this because that's going to be relevant to your lecture question. So, recap. Never compare doubles using equal. Never, ever do that. Compare the difference of the two values. Take the absolute value of the difference so you're not messing with negative values. And make sure that's less than some epsilon, some very small value, which we typically call epsilon in math. That's something we adopted from mathematics. Using a map to test your code is going to help keep you organized and keep your test cases better, your test code cleaner. And how much testing is enough? At a very minimum, enough testing to satisfy Autolab to mark whatever solutions I have, incorrect solutions I have, as incorrect. That's the minimum testing you need. You should really use more, especially on the physics engine homework. I have some functionality that I intentionally don't have incorrect solutions for. It's up to you to make sure you have thorough testing, or else when you get past the 3 numbered objectives and you get to the primary, you're going to have headaches on the primary, which should be trivial for physics engine, unless something is broken in your previous code. Then it's going to be a nightmare because you're not going to know what's wrong. Make sure you're doing enough testing to be able to finish that. You should take multiple factors. It's literally in the example on the slide, dude. So convince yourself that the testing's right. Don't think, this is an assignment I need to get through. No, are you happy with the testing? If code passes all those tests, would you be confident with it? All right, so let's try to at least set this one up. I don't have this formalized as a full lecture question because I'm just going through the example. So I'll define anything that's undefined, like the package names, etc., the class names, method names. I'll just kind of make those up as I go. But this is the next example that I want to go through. Write a method that takes a string and returns all its anagrams in a list and a test suite to test that functionality. So let's get on this one. And I'm going to start with the test. I have to define my stuff here. I'm going to create an object named anagrams, give it a method also named anagrams. Takes a string, returns a list of strings. And for now, I'm just going to give it some default output value. You'll see this a lot on the homework assignments. Just by default, I'm going to return an empty list. And we'll leave it as that for now. Now I want to write my unit testing. And I want to copy and paste from my old one. And I'm going to call this test anagrams. Clean this up a bit. We don't need epsilon. Check anagrams. Test cases are fine. Anagrams. Anagrams and alt enter doesn't work. I'm telling you, IntelliJ. I like the suggestion, but it's not working for me. So import lecture anagrams. The inputs are strings. The outputs are list of string. Clean this up. And let's give a few anagrams. So first, let's get rid of some trivial ones. An empty string should return an empty list. No anagrams of that. A single letter is going to return a list just containing that. A single letter is its own anagram. Let's do a trickier one, CSE. The anagrams are CSE, CES, SEC, SCE. And for those of you wondering what an anagram was, hopefully this example answers your question there. ESC, it's any rearrangement of the characters of the string that are possible. And ECS. So those are the anagrams of CSE, and I need one more here for some decent testing, is I want at least one input that has a duplicate letter. If you don't have that as an input, you're not even close to thorough testing. Not that there should be more testing than this with some longer words and different arrangements. What if I have a word that's just all, actually, why not add that one? That's all one letter. Let's whatever code I write should be able to handle this. And off itself, FOF, it really just matters where you're putting that O, whether it's in the beginning, the middle, or the end. So here's some tests that I have. Let me get rid of this. And we have this, and we have the next issue, pertinent to your lecture question, is I never defined the order of the anagrams. These could be returned in any order. I wrote these in just arbitrary order, the order in which I thought them up. So we're going to have lists in different order. I can use equal equal. You can use equal equal to compare lists in Scala. What it will do is take two lists and compare them element by element. So if I have these two lists, it's going to iterate over each element of each list and call equal equal on each element. So it would check, if I'm checking if these two lists are equal equal, It's going to check the first element, are they equal? Yes. The second element, are they equal? Yes. The third element, are they equal? Yes. Fourth, fifth, sixth, until it reaches the end of the list. If the lists are unequal size, or any of the elements stepping through are different, or if they're in different order, say this list had slightly different ordering. Oh, come on. Slightly different ordering. These two lists are not equal, because once it gets to this check, it's going to say these two strings are not identical because it's ESC, not ECS. Those are not equal, so it's going to return false. This equal with two lists only returns true if all of their elements are the same in the same order and the same pairwise stepping through both lists simultaneously. So equal is going to be great. It's going to be what we want, but we have to make sure the order doesn't matter. So if I give it CSE, actually this, you can't have duplicate keys in a dictionary or in a map. I was reading the chat there. In a map, so this would actually overwrite the previous one. So I can't quite do that. Can't have both of those. But what I can do is sort both of them. Once I sort them both, I don't have to worry about what order they are. Now I'm just checking, do these two lists contain all the same elements, no matter what order they appear in? So dictionary is what the key value store is called in Python. In Scala, it's a map. It's effectively the same thing. It's just called different things in different languages, if that was the question. So now I have my test cases. I can run this, and it should certainly fail. So expected this, but it just returned empty list because I haven't implemented anything yet. Can I write anagrams in 3 minutes? Let's give it a try. So if input.length equals 0, that's my empty list. Oops. Else if input.length, and Scala lets us omit the parentheses, but I'm going to add them here. Else if length 1, oh my goodness, list containing just the input. Else I have length greater than 1, or else. It's more like a threat. Else I have a length greater than 1. So what I want to do is iterate over the characters of this list by index. I obviously thought this solution out beforehand. I'm not just making this up as I go. But input dot indices. So I'm going to iterate over the indices of the characters of this of the of the input string, and I'm going to pull out each character one at a time equals input.char at index, and then I'm going to create a substring. What I'm going to do is pull out one character at a time, get a substring with that character missing equals input dot substring 0 to index plus concatenate that with input dot substring index plus 1 of input dot length. So this is going to give me the same string but with that character missing. And what I want to do who's ready for this one? This is a big kid class. Anagrams. Oh, list of strings. I'm going to call this method itself, which computes the anagrams. So if this already computes anagrams, why not just use it for anagrams in anagrams of the new string? Now, for all the anagrams that I just computed of that substring, I want to, well, for one, create an output list. I'm going to add these to the output list if I'm going to append, oh my goodness, I'm trying to go too fast here. I'm going to append that character that I removed to each one of these. Can I call that anagram? There shouldn't be a name conflict. Anagram plus the character I removed. If my output list does not contain that already, add it to my output list. Now I can use a shortcut here. If you're not quite ready for that one, this is the same as prepending this. And then finally at the end, I have to return output. Is this going to pass all the tests? Oh, actually, I have to sneak it in right here. It has to be in the else. Is this going to pass all my tests? Let's hope so. Huzzah. So this code works and it's great. But let's go back to the slides just to wrap this up quick. First thing I want to mention, that should not have been easy to follow. You really shouldn't even be able to follow the code that I just wrote. Just so you know. Most of that, I mean, I know the course goes fast, but that was intentionally way too fast. I threw some stuff at you that you shouldn't understand yet. So how do you know that my code is right? How do you believe that I didn't just make stuff up and write some random code and told you it's right? It's because the unit tests are there. Because I have testing, and I just showed you, I ran this, and I got the correct output for these inputs. And maybe you're not convinced still. Maybe you want to see more tests than just these 5. But we're at least on the right track to be confident that this code is right. And just to verify, if I say delete one of these and mess up this test, I'm going to fail it now because my test is broken. Because I returned the wrong thing there. This test is being ran on that code. That code is working. So how do you know that my code is right? Unit testing. How do you know your code is right before submitting to AutoLab, or if you don't have AutoLab there? Unit testing. And with lists, quick reminder, we can use equal to compare lists. The order must match and the elements, so we sort both lists and then use equal to tell if 2 lists have all the same elements. Let's bring us back to the lecture question. So 4 minutes over. I'll try to stop going over, but at the same time, I have people asking me to slow down, so it's a tough balance I have to hit.